Greetings, I'm Dean Whitford, Chief Executive Officer of DraftLogic Inc. Welcome to the DraftLogic Electrical Quick Start training video. In this video, we're going to show you the minimum of what you'll need to get started with DraftLogic Electrical. It's by no means a complete training course, but it'll get you going. You're most likely here because you've already seen our presentation or YouTube videos and know that DraftLogic Electrical is the highest productivity building electrical design platform. The good news is that DraftLogic Electrical is ready to go out of the box. Our installer puts the software on the system into the same state of readiness that you saw in the presentation or demo video. This includes setting up AutoCAD with a ready-to-go tool palette, including a complete set of layers and blocks, our 4 databases, including thousands of records ready to use. The purpose of the Quick Start training that you're watching right now is to get you up and running quickly. It's the beginning of your learning to take advantage of DraftLogic Electrical. But this is just a beginning. To take full advantage, you'll need to learn more. We have over 10 more additional hours of video training to help you take full advantage of DraftLogic Electrical. We have forums and in-person support by phone, chat, or email. We recommend you use this video to get started, but follow up with the other video training within a couple weeks. You can use this training video and our other ones in conjunction with our sample project that you'll be seeing today, or with a project that you need to get done anyway. So here on the right side of my AutoCAD, you can see that I've docked the tool palettes, which I can undock just by dragging away. And the tool palettes start off with the frequent tool palette. You have your high volume copy and move tools, the arrow tools, a section for layer controls to quickly turn sets of layers on and off without having to use the layer manager. And then your most often used commands and objects on the frequent tool palette. The next tool palette is the command tool palette. We've organized this tool palette in what we feel is going to be the most common order that you need the tools. So the first section is your drawing discovery section with the various tools in order of approximate need of use. The next section is systems placement. And then we have our circuiting tools, branch circuit wiring, and then reporting tools. Then we have a number of tool palettes that are your DraftLogic electrical blocks. The first one being distribution and mechanical. So here we have our panels, motors, transformers, and the like. Next, the luminaires tool palette with all of your lights. Controls, receptacles, exit and emergency, fire alarm and nurse call blocks, a variety of low voltage system blocks, tools directly related to branch circuit wiring, and at the bottom, the wire count blocks. And lastly, a tool palette of single line blocks for customizing the single line report that DraftLogic Electrical automatically builds, or for manually building your own. There's also the DraftLogic Electrical menu. Here you can launch all the same functions as you can from the tool palette, not the blocks of course, but all of the functions in the various submenus, still broken out by phase and ordered in typical order of use. We also have the Operations Center, where your most common tools can be launched from, and the tabs are your phase of work. The Operations Center also has the Reports Wizard on this tab, where you can check off specifically what reports you want to run and run a complete batch. Finally, the Operations Center also has the User Preferences tab, where you find some quick settings to control how you want DraftLogic Electrical to respond to you. Run in expert mode determines if the operations center will be loaded automatically on startup and how often it returns. If I check this on to run in expert mode, as I have here, the operations center will only come when I call it. The number of rows per page on the attribute edit form is for when you double click on a block and you're looking at the attributes of the block, how many rows do you want to see? Auto reload symbols is for when you're placing blocks manually. Once you drop one, do you want another ready to drop immediately or not? And finally, your block insertion search tolerance is for when you are placing blocks, how far away does DraftLogic Electrical look for its preferred mounting location? For example, a receptacle, how many inches away from your dropping point do you want DraftLogic Electrical to automatically find the nearest wall, bring the receptacle snapping back to it, and rotating the receptacle to the perpendicular rotation to the wall? So that's it for the tool palettes, the DraftLogic Electrical menu, and the Operations Center. The three basic ways of getting at all of the DraftLogic Electrical functions and blocks. If you're not seeing the DraftLogic Electrical menu at the top of your AutoCAD or the tool palettes somewhere in your AutoCAD, ordered similar to what I'm showing you, then it's possible that the user interface was not set up correctly on your AutoCAD. Give us a call and we'll get it straightened out for you in a quick WebEx session. The 4 libraries of information in DraftLogic Electrical drive the automation, leaving you in control of what happens throughout the process. We have a project library, which contains all of your settings relevant for each and every project you work on. A design parameter library to tie rooms into commonly used sets of rooms for projects. A room library that includes all of the room definitions that control how devices are automatically placed, how automated circuiting is done, and to some degree how automated branch circuit wiring is done. And finally, we have the luminaire library, which includes all of your lighting options. After installing DraftLogic Electrical, you should have shortcuts for each library on your desktop, and you can also start them from your Start, All Programs, DraftLogic Electrical link, and you can see them listed here. The first library, the project library, contains all of the parameters for your specific project. The tutorial project we're using today is a school. So let's go to the template for a school. We'll use our school CEC template. Copy it, because we don't want to change any of our templates. And this will be for a new school called East Glen. Now I can modify the parameters for that project. The parameters are organized into categories listed in this drop-down list with a scroll bar. In the basics, we have our project ID. This will show up on a lot of reports, so use whatever you tend to use for project IDs. Client name will also show up on some reports, so we want to fill in both of these. You'll notice some of the parameters have black colored text, whereas others have red colored text. Black is optional. DraftLogic Electrical doesn't really care whether you fill it in or not, whereas red is actually used by the automation, so you must choose a value for the red parameters. The design parameter dictates which rooms are available and allows you to control which panels are used during automated circuiting. We'll take a more detailed look at that later, but for now you can just skim down the preset ones and use whichever one makes the most sense for you. In my case, I'll stick with this one. School, 277 volt, 2x4 3 lamp, low foot candles, plus drywall. We'll see what that means when we look at it in the design parameter. Here you specify whether you want your project to follow the NEC or CEC standards, and what a drawing unit represents in model space of the DWG. The sample project is millimeters, so I must choose that. This is probably the most important parameter of them all, because if this is wrong, really nothing is going to go right. Plot scale imperial and metric, so depending on which type of drawing unit you choose, the automated floor plan layouts look to this to decide on what plot scale to make the automated floor plan layouts. And drawing numbering is an optional one, purely for your reference only. About the numbering system to be used for the plots. Our next category is distribution. Here there's a number of parameters for deciding on how you want your distribution to be calculated. Skim down them. You'll notice that all the parameters, if I hover over them, I have a tooltip. So this one, for example, it says if you check it on, it automatically calculates feeders above 100 amps to be aluminum. If you check it off, all feeders are copper. Now if I select a parameter just by clicking on it, you get the same information down at the bottom here. So if you're unsure of what a parameter is, try the tooltip, try the message at the bottom, and we also have a user manual with more detail on each of the parameters. And of course, there's more detail on each of these in the full training video series. So just to zip through some of the most critical ones, I'm going to specify that I do want my feeders over 100 amps to be aluminum. I'm going to change my voltage drop maximum to be 2.5% for my power tree feeders. We refer to all distribution plus branch circuit panels to be part of the power tree feeders. My transformer load on my parent, I'm going to say actual load instead of full kVA. Moving on to the panels category. I'm just skimming this and everything looks fine for me. Since I'm in CEC, I will leave this protection calc factor, which grosses up the protection by this percentage. I'll leave it to be 25. If I'm doing an NEC project, I want that zeroed out. And here, my service description to be used on my panel schedules, I want to leave it to be the description or name of the device plus the location of the device. What room is it in? Next category is panel demand factors and diversities. For CEC, we usually call it demand factors, and for NEC, we call them diversities. So this is already set up for CEC. If I was running an NEC project and had copied my NEC template, it would all be set up for the NEC. Fault levels are calculated automatically by DraftLogic Electrical whenever you run a report that makes use of them, so panel schedules or single line, for example. There's three basic ways of having DraftLogic Electrical calculate the fault levels. It can work from the MDP breaker, from the supply transformer specifications, or best case, if you know the utility fault current, you can just specify it. So in my case, I know that the utility fault current is 60,000 amps, so I can just specify it, and then all of these other ones are ignored, these inset ones. The last one, though, does make a difference, regardless of your method of calculation. The motor fault level contribution FLA multiplier, I'm leaving it set at 5. Branch circuit wiring. Here is where I would choose the maximum number of circuits for home run. I'm going to be having 3-phase branch circuit panels, so I'm going to specify 3 here. And the maximum voltage drop allowed for branch circuits, I'm going to change this to 2.5. Now remember, this only applies to the branch circuits. The other half of the voltage drop was specified in the distribution, and I also changed that one to 2.5, giving me a maximum 5% voltage drop throughout the system. On my motors tab, I decide whether to circuit large motors to the MCC, the MDP, or a power panel. If I say MCC or MDP, it'll only circuit to them if it finds them. If I say power panel, DraftLogic Electrical will put down panels as allowed to circuit motors to. I'm going to specify the motor control center. Here is where I tell DraftLogic Electrical how to treat motors. Small motors can circuit with other motors and or other receptacles, depending on your next choices, whereas large motors will always be circuited and home run separately. So here's where you decide what FLA that cutoff happens at. I've got mine set quite low at 0.8 right now. We'll change it to 2. The following 2 control whether automated circuiting will include small motors in receptacle circuits or not. yes or no. And further, which will of course override that, do you want all motors circuited separately, regardless of whether they are small or large? Next, do I want heaters to be included in the motor schedule, yes or no? And what percent of MCA for motor feeder voltage drop calc? Lighting has a number of parameters that are carried into the room ID fields. So these are defaults that carry into each room, and within AutoCAD at each room you can change these. So most important just to put, for all these three reflectances and the ceiling height, what's the most common number you're going to see in your project. Put it in, and you can deal with those that don't have that particular value once you're in AutoCAD. The top one here, lighting circuit load, is based on the wattage allowed by code. So not the maximum wattage that the circuit will allow, but that code will allow on that circuit. Do you want to apply some extra buffer or not? So setting this to 100%, for example, would tell DraftLogic during automated circuiting that it can do my lighting circuits up to 100% of that allowed by code. At the bottom here, you have your preferences for the automated luminaire tags, whether you want them to be 1-to-1, so one tag per luminaire, to be dense, thin, or have one per room where applicable. I'll select thin. The buffer is how much space do I want around them. You'll notice it says inches in brackets here. Even though I have a millimeter project going on, we needed to choose one set of numbers to have all of these parameters work by to prevent confusion and programming issues. So all of these types of settings are inches, and they're converted by DraftLogic Electrical into drawing units as needed. So here's the buffer, the free space you would like around the luminaire tags. And this one is the maximum distance that a luminaire tag will be seen to be able to service a luminaire. So how far away it can be deemed as working for a particular light. The scale at which the luminaire tags will insert, and whether luminaire tag placement should attempt to avoid XREF entities or not. Power, which is also basically referring to receptacles. We have a similar circuit load allowance. I'll bump this up to 100. And then some settings for the minimum protection. This was also on the lights one. For CEC, you may go 15 or 20 amps. For NEC, typically you'll go 20, but of course you might go 15. My project CEC, I'll stick with 15. And then there's some branch circuit wire related settings. How many receptacles can branch circuit wiring associate to a junction box? How far away from a junction box should it look? And how far above the floor or the counter is the receptacle considered to be mounted. Finally, we have some distances and modifiers. These are both important for your power tree, aka distribution, and for your branch circuit wiring amongst the utilization devices. So important for a project, whether you're running your branch circuit wiring to get a detailed bill of materials and possibly do a ConEst IntelliBit export, or even if you're not doing that, you still want to take a look at these because you want your distances between your distribution devices to be calculated as you desire. So the first one, average floor-to-floor height between the floors of the project. The next one, how far from the main distribution panel to the utility supply transformer. That's in feet. And then we have some adjustments for overhead feeder to the same floor, in-slab feeder and home run to the same floor, all feeder and home runs to different floors, a fixed modifier for all feeders and home runs, and then a modifier that applies only to the branch circuit wiring interconnects. Basically, how much slack do you want to allocate between the utilization devices during branch circuit wiring? So that's the project settings. DraftLogic Electrical will look to the relevant project settings whenever you run an automated process. And for that automated process, it will use the project settings as they were when you executed the process. So important to remember that if you run automated circuiting with the values that affect automated circuiting in one way, and then later change those values, remember you need to rerun automated circuiting to have the new values take effect. Let's look at the room library next. So the room library, like the other libraries, comes pre-populated with many definitions ready to go. For example, let's look at one of the library definitions. So the first tab in any room definition is the lights. There's a checkbox for you to indicate whether you want foot candle based lighting to happen or not. That's lighting that looks to the space, the foot candles you've decided on, and the fixture that you've indicated, and then we'll put in enough fixtures and spread them around the space to light it to the foot candles that you've specified. You can also have lighting rules. Each of these will look for a particular reference object or a particular location in a room to be placed. These are explained in detail in the user manual, although most of them are named well enough that you'll understand what they are. For example, you may want chain-hung fixtures over workbenches throughout the room. So just by double-clicking on it, you turn that rule on for that particular room definition. At the bottom, we have a checkbox where you specify if you want to allow automated circuiting to have lighting circuits share into this type of room or not. So for example, our corridor definitions, we have this defaulted off. The next tab is where you specify how you want the room perimeter-based receptacles to be done. So these are the receptacles that go around the perimeter of the room, what receptacle type you want to use, how much wattage they should be assigned. This will control how many receptacles can end up on a circuit. So if you want to limit it to 4, you would need to figure out what your circuiting allowance is for wattage for receptacle circuits, and then factor that down by 4 and use that wattage here. And the maximum distance that you want between your receptacles around the room perimeter. You can optionally force unshared neutrals during branch circuit wiring later, and single circuit home run if the receptacles are expected to service sensitive equipment like computers or something. Again, we have a rule-based section, this time for receptacles, and in this library we already have some selected. For example, it's going to look for desks and place a receptacle near them. It's going to look for photocopiers, shredders, and faxes and put a receptacle behind them with a wattage rating suitable for that use. And finally, look for tables and put a flush floor receptacle under the center of them. Again, we have a checkbox here to indicate whether you want receptacle circuits to share into this room definition type or not. The last tab has some general features. What is the default ceiling type for this room type? That will go into the room ID block where you can change it for particular rooms if you want. A room category specification for what type of room this is. Whether you want branch circuit wiring to exempt this room type from conduit through routes. And finally, the search strings that DraftLogic Electrical should use. These apply when you're using automated room creation to look through a good DWG to automatically create your room boundaries and to completely populate your room IDs with the room type. Going to look for these strings in the architect's notations and based on the weighting, assign a room type to them if it finds it. So that's the room library. You notice at the top, as in the other libraries, we have new button, copy, rename, and delete. So you can copy existing definitions if you want to start with one and just change it a little and have another one permanently in your room library. You can make a completely new one, rename any of them, delete them, and here we have an Add to Design Parameter button. We'll talk more about this as we go into the design parameters next. With over 1,450 room definitions, you don't want a list like that showing up in AutoCAD in a drop-down. That's one of the jobs of the design parameters. Let's take a look at the design parameter library. So at the top, we have our design parameter name with the usual new, copy, rename, delete buttons. We have a different button, make current. So this changes your active project to have the currently selected design parameter as its design parameter. The first tab is for rooms. On the left side, we see all the available rooms. So if there's none selected, this list would include every room definition in the room library. So right now, over 1,450. Selected rooms are the ones that you think you might need in your current project. Selecting them in this list just makes them available in the drop-down list inside AutoCAD. So you want to keep it to a manageable level so that that drop-down isn't too busy for you. But you can be generous about including rooms that you're not sure about whether you'll need or not. Double-click to remove from that side, double-click to add from this side. You can highlight multiple using whatever Control-Shift method you want, and then use the left and right arrows to move them over or back. I can reset it to how it was originally before I made any changes. So you may have noticed that the design parameter library opened up with the design parameter that we selected for our active project as the active one here. So if we look at our project library, we can see that the design parameter for our active project was defaulted to when we open this up. I can also change my active project. So if I copy this with something to let other users know of what the difference is between this and the original one. So I'm adding an apparatus bay. So now I have a new design parameter with the apparatus bay added. So if I save that, I can click Make Current. I get a dialog to confirm that I want to add this design parameter to make it the active one for my East Glen project. I'll say yes. Now if I peek back in the project library, you can see that this new design parameter is now active here. So that just saves some clicking going back into the project library to manually make this the current one. There's a similar integration between the design parameters and the room library. So in the room library, for example, if I copy this apparatus bay again, but this time let's make a 347 volt version. Change this to 347. Select the 347 volt fixture. Save it. So now I have a 347 volt apparatus bay in my room definition list. You can see it updated automatically over here in the available rooms. Let's say that I know that I want this in my active design parameter. Well, on the room library, I have this button to just add it. So I get a confirmation dialog letting me know that it was added successfully to this particular design parameter. And I can see over here in the selected rooms that it was added for me. Now also on the design parameter library, we have another tab. This is the panels tab. Your selections here only affect automated circuiting. They do not restrict in any way, shape, or form what you can do manually circuiting. So here you just check and uncheck whether you want a particular panel type to be allowed to be used for automated circuiting or not. And when DraftLogic Electrical runs into a device that it wants to circuit, it looks to here and will place the first panel that will meet that need. So if I check this off, then all of my 120-208 product that will work on a single phase panel will be placed on a single phase 3-wire 120-208 panel. But I don't have that checked off. So instead, it's going to use a 120-208 3-phase 4-wire panel. And since this project I have mostly 277 volt lighting, I've also allowed automated circuiting to use a 277 480 3-phase 4-wire panel. If you want your manufacturer and part number to be filled in by default, you can fill that information in now. And also, of course, specify the default size you want used for your panels and whether they should be recessed or surface mounted. So doing these things here will save you some clicks later on in dealing with individual panels that have been placed. Once you've made all your changes, you just save it. So the design parameters stay in the library to be used by one or many projects. Same as the room definitions. They're used by one or many design parameters. The only information in the libraries that is meant to be used for one particular project is in the project library. And of course, you can still copy those if you want to use same or similar settings for future projects. Our last library is the Luminaire library. On the left, we have a hierarchical browsing tool where you first can see your lighting categories, and then for each category, you have a subgroup of either the fixture dimensions or, where applicable, by wattage. And then the next level for both types, of course, is voltage. So once you've expanded all of these subgroups out, you see the actual luminaires that are within those subgroups, and you can click on them to see their information on the right. This is all grayed out now because the first 90,000 records are locked. Your site administrator can change them, but we've done it that way so that in future shipments of the Luminaire library, we can add to the first 90,000 records and ship them out to you without disturbing any luminaires that you have added at your site to share with yourself and other users there. So best, if you're going to add luminaires, to add them at higher than 90,000, which is what happens if you click New, you start at 90,001, or Copy. It automatically gives you the first available number above 90,000. And now everything is available for you to edit. In the lower right, we see the fixture detail. By clicking on View Detail, we can see that full size. This is the same graphic that goes into the Luminaire catalog, which is automatically generated for each project for you to distribute to your client if you desire. And it's also visible inside AutoCAD off the attribute editor if you just want to see what a luminaire looks like to ensure that you're selecting the one you really want to use. So that's the 4 libraries. Drawing preparation, or drawing discovery as we like to call it, is where we get the drawing ready to take advantage of DraftLogic Electrical's automation. It's similar to the process you may already be using to get your drawings ready for work. Cleaning up some block and layering issues, and for DraftLogic Electrical, going further and ensuring that you have an inside perimeter for each space you want to recognize, and an outside perimeter for each floor you want to recognize, plus some identifiers. DraftLogic Electrical can handle a variety of source, ranging from PDFs to raster images like JPEGs or BMPs, and of course good quality and bad quality DWGs, whether they came from AutoCAD or were exported from another platform like Revit or ArchiCAD. For this video, we're going to assume the worst case, that we have a bad DWG and need to just manually draw our room and floor boundaries. The goal of drawing discovery is basically to get through it as quickly as possible with good quality boundaries and the minimum of what you need to proceed. I mentioned earlier that the most important project parameter is the drawing unit represents setting. Because of that importance, we have a check that happens whenever you open a drawing to verify that the drawing is set to the same units of measurement that your active project is. So I'll just open a blank drawing. So here is the check saying that there's a problem, that the drawing units, unsupported units, meaning this new drawing doesn't have any units assigned to it, and the project settings, which are set to millimeters, are in conflict. Do I want to force the drawing to have the same unit setting as the project settings? And in my case, since I'm opening a blank drawing, I would of course say yes. The only reason you would say no is if you're opening a drawing that already had valid and proper units assigned to it, for example inches, but you had accidentally left the project library set to a millimeters project, and you need to go and change that. In that case, you would say no, but in all other cases, you'll say yes, I do want to assign the active units to this drawing. So now, this particular drawing has millimeters assigned to it. It's a hidden tag for DraftLogic Electrical's use only. So if I save this drawing and then reload it, you can see that I don't get that drawing units challenge, because now this drawing has millimeters assigned and I loaded it with a millimeters active project. On the other hand, If I now go to my project library and instead select one that I know to be inches as active, and then reload the drawing, I will get the challenge box saying that the drawing units, millimeters, and the project settings, inches, are in conflict. Do I want to update it? Well, in this case, I know that my drawing really is millimeters, and I want to keep it that way. My mistake was having my project library left active on an inches-based project rather than the real project I want to work on, which is this one. So in this case, I would say no, load the drawing, change my active project, and now DraftLogic knows, you can verify by going to the Operations Center, that East Glen is my active project and that my drawing unit represents millimeters. So here we see an architect source drawing for a small school. In reality, this drawing is very clean and well done. All of the layering is well standardized, and a fixed block has been used for the room IDs. So this drawing is a great candidate for drawing mapping and automated room creation. Let's pretend for a minute, however, that this is one of our less preferable types of source. So a PDF without any discrete layering, or a raster image, or just a badly done DWG. For example, if the architect drew everything on one layer. Well, the time to clean those other sources up is too much, so we treat it as our worst kind of source and merely want to go in and come out with inner perimeter room boundaries, outer perimeter floor boundaries, room IDs, and a floor match block. So I just quickly use this room boundary tool to draw my inner perimeters, and they don't have to be super exact, but the tighter the better to the inner perimeter of the room. So I'm just going around with O-snap and close that last line with the C command. Very important to do that. Don't click around until you're right on top of your starting point. Always use the C command to close that last line. So the room boundary command automatically says, where do you want your room ID? I'll put it here. And I get a room ID block, select my room type. Pushing the first letter takes me to that area of the list. This will be a classroom. And then the room description. Usually you want a room number in your first field here, and then up to 10 characters in the second one. Now, if we run automated room creation, it grabs all the information from those room ID blocks automatically. So the ceiling height and reflectances, as I mentioned earlier, they come as defaults from the project parameters that you set up, and you would just alter them if needs be for each particular room. So let's say that this is actually a bit higher ceiling of a room. Say okay, so there, that room is done now. You can see we have this inner perimeter on the ZDL room boundary line, and we have the room ID. Similarly, for the floor, so we would go through all of the rooms, all of the spaces, and do that. Usually you're going to follow a room boundary, but if you have a space where you want part treatment in one area and part treatment in another, you would use more than one room boundary inside that room and cut it into multiple spaces. This might happen, for example, in a corridor where there's corners and stuff, and you want to treat the sections of the corridor as more rectangular spaces for better generic lighting placement. Or, for example, a large room which has half T-bar and half open ceiling, and you're going to want a separate lighting treatment for each area. So for the floor boundary, I'm first asked about the floor identifier. It's important to use a floor identifier that reflects where that floor is. So is it the ground level? That would be floor 1. Is it the floor above floor 1? Well, that would be 2. Or is it kind of a mezzanine half height floor between floor 1 and floor 2? Well, that would be 1.5. That number is important because it's used as a multiplier for your average floor-to-floor height for calculating the distance, both during branch circuit wiring automation and by the code that does the calculations for your distances between the distribution devices. So in this case, if you're intending on using branch circuit wiring, you want your floor boundary nice and tight. But if you're not intending on using branch circuit wiring, you can come out a bit. And you must leave enough room at least for the insertion point of any exterior devices. So if you're going to have any exterior plugs or lights, you want to leave just a little bit of a room so that you can have those devices on the exterior of the building and still have their insertion point, not necessarily the whole block, but at least their insertion point within the floor boundary for the floor that they belong to. You may also want to leave room for any exterior parking lots in case you're going to have plugs for those winter climates. So I'm just going around approximately the exterior of the building. If I wanted to have good branch circuit wiring automatically done, I would go a little tighter. I'd go to the actual exterior line, except of course leaving space where desired for those exterior lights and plugs. And same with any polyline, both in DraftLogic Electrical and any other work you do in AutoCAD. Don't try and close it off yourself by clicking on your starting point. Instead, remember where you started, and when you come even with that, just push the C to make the last line. Here I started a bit in, so I'm going to go just out here and then C to close it off. And I'll let AutoCAD close it off so I have a nice closed polyline done up without any extra vertices in it. So that's the basics. The room inner perimeter boundaries or space inner perimeter boundaries, the floor outer perimeter boundaries, room ID tags for each space, and lastly we need a floor match block for each floor. Even if we only have one floor, this floor match block is a tiny block that won't show up on any plots, and you need to put it at a vertical corner that is the same for the entire height of the building. And what that does is it gives a reference point for all of our distance calculations so that we get both the horizontal and vertical distance correct for our calculations. Now you see on the command line that I'm being asked again to select the location to insert the floor match. My floor match did go in. It's way down here. You can see the small blue crosshair type thing there. And on my cursor you can see another one loaded up ready to go. That's auto reload. So the assumption is that you're going to do things in batches and that it's handy to have the next block ready to go. So you just click, 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 click to drop. And that's auto reload by choosing another command. For example, skip room. DraftLogic Electrical automatically cancels the reload and you're on to the next function. So that's how we prep bad source. We manually draw our room boundaries and place all of our room IDs. There's some shortcuts associated with doing that, and there's also a treatment for good DWG source like we'd get from an architect who follows good layering standards or from a Revit export to DWG. And in those cases, it's best to use the drawing mapping and automated room creation process to get lots of extra information in the source that's really good for automated branch circuit wiring to use because it can take advantage of knowing where you have door swings, windows, counters, and the like. And also automated placement benefits from knowing where those door swings are because it won't place room perimeter receptacles behind them. If you want to see the steps of using drawing mapping and automated room creation to take full advantage of good source, that is covered in detail in one of the drawing discovery training videos. So I'm not going to cover that now. So here I've loaded up my drawing with good room perimeters for all of the rooms and room IDs that were created completely automatically by automated room creation. So we can see the room inner perimeters here, room IDs here, and this room type was chosen automatically, and these room description lines were filled automatically through the automated room creation process. So it saves me a lot of clicking and typing versus doing it manually like you saw the example there. So at this point we have our 4 minimum requirements for the whole drawing. We have room inner perimeters, room IDs, floor outer boundary, and floor match block. So here's where I've used the layer controls to make sure that all my DraftLogic layers are on. And I turn the XREF off. Depending on how the XREF was prepared, the source on and off buttons in the frequent layer controls may turn it on or off. Otherwise, you'll have to use your layer manager in the typical way to turn your XREF off. So all that I'm left with now is the DraftLogic working layers. None of these actually go to a plot. Only the devices, branch circuit wiring, if any, home runs, and the XREF will go to your floor plan plots. So all of the entities that you see here are purely for DraftLogic Electrical working purposes. So during the drawing mapping process, some counters were created on the ZDL counter workbench layer. And if we temporarily get rid of this room boundary, we can see that behind it we have walls and windows and some door elements. So these will all be used during automated placement and branch circuit wiring to give us higher quality results for things like room perimeter receptacles and for the distances between the branch circuit wiring interconnects. Since we have our doors and walls as known entities, when branch circuit wiring is connecting, for example, two receptacles on each side of a door, it will know that it needs to go up and over the door rather than straight through that wall space. In my sample school here, we can see there isn't any T-bar at all. Sometimes you'll get that from an architect, sometimes they'll include it. If they include it, you can use it. That's talked about in detail in the drawing discovery videos, but really you're just moving it on to the ZDL T-bar layer. If you don't have any at all and want to create some quickly, we have a number of tools to do so. You can create it room by room to get specialized patterns per room that vary versus neighboring rooms. Or if you want to have a contiguous grid throughout your floor plan, you can use the mass ceiling grid tool here. So since this is a millimeter drawing and I want a 2x4 pattern, I'm going to go 1220 by 610. You can see the numbers going in on the command line. Throughout your use of DraftLogic Electrical, it's important to keep an eye on the command line. Always have it stretched out to 4 or 5 lines minimum. We do a lot of notifications and input requests there. So a lot of important information showing up on the command line. So it selects any room to be your sort of base room and asks you if you want to use the middle of this room as the middle point for all the rooms, which would mean that the grid would go across your floor plan contiguously. If you say no, which I'm going to do, what it'll do is use the middle of each room as the center point of the grid for that particular room. Finally, we're asked about rotation angle. Do we want our T-bar to be something other than 0 rotation? I want 0, so I'm going to just choose enter for the default of no rotation. So in a fraction of a second, you can see that DraftLogic Electrical has gone through the floor plan. We have some rooms with T-bar and some rooms without it. You'll note that the rooms that do have T-bar, the center point of the room was used as the center point of the grid, going outward from there, so all of your partial grid pieces are on the perimeter of the room. Now, why did some rooms get it and some rooms not? Well, let's look at the room ID block. This classroom, for example, the ceiling type is T-bar, so it was given the T-bar. This neighboring vestibule, however, had a ceiling type of drywall, so no T-bar was applied. So mass ceiling grid goes through and applies T-bar to the rooms which have requested it and ignores the rooms that are drywall or open ceiling or otherwise. So that's the core tools and core requirements of the drawing discovery phase of work. We have a couple quality assurance routines. One of them checks the 30 or 40 most important items about your drawing. These are to do with the room boundaries, floor match, and room IDs. So let me just use my all on frequent control here to turn everything on and do some bad stuff, and let's see what happens. So if I go, for example, take my room identifier insert, just plunk it outside the floor plan here, And let's throw a floor match outside the floor plan. So I've done a couple of bad things. I'll save this drawing. Now let's reload it and see what the drawing validation tool comes up with. It's the same function that runs if you do your check blocks and polys. So if I reload that, you can see that our DWG validation tool dialog box showed up here, meaning there's some issues. It advised that room or floor or other block and polyline related issues were found and is listing them. It found one room ID not in a room and one floor match block not in a floor, and advised me that error arrows were placed for these. This tool will also fix some problems completely automatically. For example, if you created a closed polyline that had some extra vertices in it that were right on top of each other, those would be removed completely automatically. No work for you to do, but the validation tool would let you know that it had done so. So I'll say OK here, and I can use my error arrow tools to zoom to my first arrow. So floor match block not in a floor boundary, just zoom out a bit and select it here. So you can see if I list, I have two found, the error arrow, the floor match block. So I can just select all that, delete it. Room ID not in a room. Well, we know what that was all about, so let's just delete it. Usually you're going to have to take a look at these issues and ensure that they're resolved so that you'll get the results you need. So if I rerun that test myself now, it's the same test that runs when the drawing loads. I don't get a dialog. I just get a message at the command line saying that no room and floor issues were found and no other block and polyline issues were found. So my drawing is clean. For more information on what the validator tool checks, its error arrows, and how to resolve them, we have lots of detail on this in a forums entry. So that's the basics of drawing discovery. You can learn how to use the rest of these tools and the other methods of getting other types of source prepared by watching the full-length drawing discovery training videos. In the systems placement phase of work, you can use DraftLogic Electrical's automation to automatically place certain types of devices. And of course, you can manually place devices or modify those that were automatically placed. DraftLogic Electrical provides a variety of tools to help you in both scenarios. Once you're done placing your systems, regardless of how the devices made it to where they were, as long as you have used the standard DraftLogic Electrical blocks, DraftLogic Electrical sees all placements as equal. There's no differentiation between those that were automatically placed or manually placed. Now that we have come out of drawing discovery with our minimum requirements of room inner perimeters, floor outer perimeters, room IDs, and floor match blocks all met, we're ready to do systems placement, basically getting all of our utilization devices into the drawing. If we created all of the room definitions we needed or found them all pre-existing in the room library, automated placement is an excellent way of getting a huge head start on your systems placement. I'll run it now on our sample drawing here. So I'm asked at the command line how I'd like to select the objects, all, polygon, by room type, or by selection. I'll choose the default all just by pushing enter. It asks me which systems I want to execute. I'll do both fixtures and receptacles. So now what DraftLogic Electrical is doing is it's going through the drawing room by room and looking to the room library for those 4 types of placements that we examined. So the room perimeter receptacles, the foot candle-based lighting, rule-based receptacles, and rule-based lighting. And for each room, it's executing all of those types of placements. So we see on the command line that in about 1 minute and 40 seconds, we had 50 rooms processed, and they all have their generic lighting, room perimeter receptacles, and any rule-based equipment that was placed. Let's look, for example, at the library. So if we want to know what we were to expect for the library, we have a showroom record tool here which will automatically bring up the room library at the room definition you click on. So this is the exact room definition that was used for that library. You can see that in the room definition we asked for 2x4 3-lamp lighting, 277 volts, and that we wanted the space lit to 35-foot candles. We didn't have any rule-based lighting selected. We wanted duplex receptacles assigned 200 wattage, spread with a maximum distance between them of 240 inches. We also had some rules: desk receptacles, photocopier receptacles, under-table flush floor receptacles, shredder receptacles, and fax receptacles. So for any of those devices or reference locations that were found, we're going to get the specialized receptacle that we called for. So let's see how that worked out. So here's our luminaire, 277 2x4 3-lamp as desired. We have a view detail button here if we want to take a look. We have room perimeter receptacles. They avoid going behind counters and behind door swings, and they're assigned 200 watts as we requested. The usage field is only used for suite D rating, so you don't see every possible use in here. It's only the ones that apply to suite D rating. So general purpose is fine for any sort of non-suite type situation, although you can of course assign a particular usage if you want. It just won't do anything in particular. It's for information only. So here a copier was identified because we had this ZDL copier closed polyline, and at the back center, snapped to the wall, we had a plug placed. It was assigned an equipment tag of copier, a 1200 watt wattage automatically. And beside it, a shredder. These tables were found, and the floor double was placed with 1200 watts. At the bottom of a lot of receptacles and other similar devices, you see a non-coincident group ID and subgroup. These are for DraftLogic Electrical to completely automatically take care of non-coincident device calculations for you. At any point where you have devices with the same group ID and a different subgroup ID coming together, for example at a branch circuit panel or possibly a central distribution panel, and of course the MDP in the end, DraftLogic Electrical will calculate at each of these points which subgroup of each group has the highest wattage and use only that group for the wattage calculations at that distribution device. You also see luminaire tags have been automatically placed for us in compliance with our settings in the project library. If you don't like what you got for luminaire tags, there is a tool to just remove them. Remove the fixture tags, and then change your settings in the project library and just run the auto fixture tags. So everything else will be left alone, and it's just the fixture tags that will be rerun. Automated placement also dropped some error arrows for us. Most of these are actually just warning arrows about collisions and things like that. So for example, where the application couldn't determine a spot for a luminaire tag or a good spot for a receptacle, it has put the device or tag down anyway because we need it, but given us a warning arrow to say, hey, I couldn't quite put it really where I wanted to. So easy solution for us. We have these high volume copy and move tools. So high volume move, for example, you just launch the tool by clicking on it. Your first click selects what you want to move. Your second click drops it. And you'll notice, especially where you have some curved walls or non-orthogonal walls, that DraftLogic Electrical will automatically snap and rotate wall-mounted devices to the nearest wall. So I'm not even clicking particularly near to that wall, but DraftLogic Electrical is still finding the wall and snapping back and rotating for me. This saves a lot of clicks and typing and figuring things out. The same works for any ceiling mounted devices that are supposed to go in T-bar. If I pick this fixture up, just click anywhere within this cell, it snaps and rotates into the cell automatically for me. So if you don't like how the fixtures were arranged, it's very quick. to do some simple rearrangement and stretch them out. You can, of course, use all of the standard AutoCAD tools for things like array, multi-select, and moving. So once you've gone around the drawing and dealt with all of the warning arrows, either by simply deleting them or perhaps dealing with the issue that they brought up. For example, this switch was unhappy about where it could go, so we definitely want to move that. Sometimes you won't be happy with how foot candle-based lighting treated a space, and you may want to make a large change. So for example, this corridor here ended up with the ceiling grid being split because it's L-shaped. So perhaps I want to remove the ceiling grid by selecting the polyline and then put a new grid in just for this room. I'll go with a 2x2 grid. You'll notice that I was asked to build a selection set, so I could select objects and do a crossing select for one or many, and then to close the selection set, I just did a right click or enter and got to the next question. Start point for the T-bar to be calculated. Well, I want to make sure that I have a nice row of cells down the middle here, so I'm going to start right about here. Now, of course, I could have measured and left a guiding line or guiding point for me to click on, but for our purposes today, this is good enough. Now we have the Luminaire Adjust tool in the Systems Placement area to make the change to the type of lighting. So here at the command line, I'm prompted to select a room boundary or room label. It'll advise me what lighting has already been placed in there. So I'm going to change to a 2x2 3-lamp, sticking with the 277 volt. I choose from the available fixtures. Take a quick look at it. I'll leave my foot candles as they were. Now I can either just click change to change it, or I can calculate and get an approximate idea of how many luminaires it's going to want to place, and then say change. So DraftLogic Electrical will remove the old lighting, put in new, and then I can use my high volume move tool to make any tweaks that I want. So that's automated placement and some of the tools to help you move things around that you're not happy with where automated placement put them. If you didn't delete the error arrows as you went along, there's a one click here to remove them all. Now let's put in some other systems to this drawing. DraftLogic Electrical can place branch circuit panels automatically for you during automated circuiting. But motor control centers, main distribution, and other distribution devices will need to be placed by you. So I'll place an MCC. All of the distribution devices refer to a number of circuits. It basically means a number of connections. We do it that way so that we can do things like associate them in the single line and produce pseudo panel schedules for everything. So even a device like a motor control center that doesn't necessarily have a breaker box, we treat it as having a number of circuits. For all of your distribution and a lot of your primary devices like motors, there's a lot of overrides down at the bottom. So your top section is the base required information like phase and voltage. The next area is a lot of calculated and assigned things like circuit numbers, feeder specification, protection assigned, etc. And then we have a lot of overrides. So on the MCC, for example, you can specify the minimum protection size, you can specify an exact size of protection, you can specify a particular type of protection, a feeder, a bonding, a bus. You can force a parallel feeder, and finally, any distribution device that's similar to a panel will have a series of adjustment percentages, so load adjustment percentage and different diversity percentages for those types of loads that might be circuited to it. You can also override the feeder length and finally supply a manufacturer and part number. I could put in my main distribution panel. For this project, I'm going with a 277-480 main distribution. Let's put in some HVAC motors and small exhaust fans. Auto reload will carry over attribute values that won't cause a conflict with a prior device. So the unique name will be different, but the equipment tag will be carried over, as will any of the overrides that I select. For example, if I want the control type to be remote start stop and the protection type combination mag starter, and also the remarks, which will carry into the motor schedule. So there's my first HVAC motor. By taking advantage of auto reload, the copy tools will do the same, but auto reload carries forward all of that. You can see that my control type stayed at the remote start stop, that my equipment tag is still HVAC. Unique name automatically rolled forward. Any device that does have a unique name, we're assigning an automatic name to it. And these automated names can be changed somewhat in the database. Give us a call if you want to discuss how to do that if you don't like the format that we've provided. My protection type override stayed the same and my remarks rolled over. I'm going to make this a larger one and assign a particular horsepower to it. For motors, you need to provide something. You need to either provide MCA, MOCP, or an FLA override, or enter a horsepower or a wattage. And based on what you enter, all of the other values will be calculated for the motor. If you do want to enter an FLA, don't enter it here into a calculated value. Instead, enter it into the override field here. So I'll place a third HVAC motor, and again change up things just a little bit. Now we'll have some exhaust fans for, say, a science classroom over these counters. These are just little guys, so we'll assign a wattage. And again, take advantage of auto reload. So although I did get most of my luminaires placed by automated placement, I can place as many as I want myself. I can remove those automated placement ones. I could skip automated placement. There'll definitely be spaces like perhaps a showroom or executive boardroom where you want a very particular lighting treatment and you'll need to place it yourself. So we have all of the luminaires available for placing on your own. But of course I want to stick to my 277 volt lighting pattern. If I do want to have exterior mounted devices, I need to have them both within the floor boundary for the floor that they're part of and within a space boundary, which doesn't have to be very large at all. So for example, if I want this HID outside here, along with a weatherproof plug, so I've put them on the wall, and I just need to zoom in and give them a space to live within. Doesn't have to be very big, just big enough to capture their insertion points. And C to close that polyline, as always. Insertion point of the room ID just has to be there. For exteriors, we don't worry too much about ceiling heights. So there we have our room ID with its insertion point inside the room. The light insertion point, receptacle insertion point, and room ID insertion point are all inside this little space. Now my OSNAP grabbed the corner of the room boundary here. I'm going to just move off it to make sure that there's no overlap. So that's how you work in exterior devices. Let's put in some emergency floodlights and some exit lights. So I put this wall battery pack with 2 heads. You can see it snaps and rotates to the nearest wall. I'll just do a few to provide an example. And then some exit lighting. Although they don't take part in automated circuiting or automated branch circuit wiring, we do have a full set of blocks for fire purposes. So we have the fire annunciator panel, and we have the detectors and alarms. And a complete set of low voltage blocks. So even though they're not automatically circuited or branch circuit wired, all DraftLogic blocks still snap and rotate to their mounting reference, whether that's a wall or a T-bar. So now that we have good representation of our systems, I'm not going to do everything, of course, that we need to do for a production project, but I've done enough to provide you with an example. We now may want to designate some of that lighting as emergency lighting. So if you go to the circuiting section, you can select EM powered lighting. So lights that are already going to be circuited as emergency come up in purple. So all of those floodlights and exit lights came up. But we will want to assign some extra ones as being emergency. So just by clicking on them and building a selection set, and by right-clicking, I close the selection set. Now when I close it, any block that has an emergency counterpart in the database is automatically swapped. So this used to be your standard 2x4, but it was automatically swapped to the 2x4 emergency powered style. And then when I'm all done, as per the command line, press enter without selecting any objects when finished. I can also designate motors, receptacles, any device to be emergency powered. So that's the basics of systems placement. As long as you use DraftLogic electrical blocks and layers, which are automatically managed when you use our tool palettes, you can use any way of getting those blocks into the drawing on the right layers. This includes DraftLogic electrical automated placement, manual placement using the DraftLogic electrical tool palette, manual placement using any AutoCAD function that you want, or manual placement using your corporate tools. It doesn't matter, as long as it's the DraftLogic electrical blocks ending up on the correct layers. DraftLogic Electrical will see all of those placed devices as being equal for future phases of work like circuiting, branch circuit wiring, and reporting.